All right, our exit ticket. All right, in a carnival game, players get 5 chances to throw a basketball through a hoop. The dot plot shows the number of baskets made by 20 different players. So 5 shots, 20 different people. So there's 20 dots here. Make an inference by looking at the shape of the data. So the shape of the data, it's a nice rolling hill with very few of us missing, or very few of those players missing 0 shots. People made shots, and if they made shots, they we're in a range of really making 2 to 4 shots. And it was kind of rare for someone to go in there, just as rare as it was for them to go in there and make 0 to make all 5. Um, so an inference is that if you are to play this game, you have a pretty good chance of making 2 to 4 baskets based on this data of these 20 different players. That's pretty good. I mean, you can go and look at what rewards or things you can get if based on this many baskets, I'll earn this at this. So it's a good thing to kind of see that. Um, Part B, what is the median of the data and what is the mean? Do these measures of central or center support the inference you made in part A? Depends on what inference you made, right? But the median, it looks like it's going to fall on a 3. So I'm just kind of counting how many dots there were. I had 9 dots to the left of 3, 7 dots to the right. So there's my 9th. Yeah, we'll fall on 3. So our median is going to equal 3. And our mean, also known as our average, is probably going to land almost right smack on 3 as well, maybe 3.1 or 3.2. You'd have to add these all up and then divide it by 20 to get your mean. I just don't have that right now, and I don't want you guys to wait for me to calculate that. But either way, does it support my inference? The idea that I think someone will make between 2 to 4 shots. Well, between 2 to 4 is exactly that 3. So it does support it. Our measures of center support the idea of where we're kind of visually seeing the cluster and how many shots that I inferred that people would make.